So as we are graphing and starting to work with our graphing of trait functions, the first thing we do is we're going to look at a unit circle. Thank you, sir. But I don't want to look at the entire unit circle right now. What I want to do is look at the quadrantals. And remember, where are the quadrantals again? Yeah. So instead of looking at this whole mumbo jumbo, what I'm going to do is say goodbye. I'm going to look at my quadrantals. And what I want to do is look at the ordered pair sets for the quadrantals. What was the ordered pair here? 1 and 0, okay. Here it is. Okay. Now we remember that in your ordered pair set, it's x and y. The x value goes with cosine, and the y value goes with sine. Do we agree? So if I want to look at this graph like this, and I wanted to just look at the physical graph of what sine looks like, I'm going to look at the following scenario. Ooh, that one. Sorry, I hit the wrong button. Y equals sine of x. I want to look at that graph. What that means is I want to look at all the values. I want to look at what the graph of sine looks like. Now, here's what I want you to do real quick. Take your calculator out, make sure you are in radian mode, and just go to the y equals button and type in sine x, and hit enter. Radian, yeah, make sure you're in radian. Y equals sine of x? Typed it in wrong, guys. Yeah. So it's looking kind of like this. Something like that, right? Or somewhat similar to that. So what's happening here is sine is oscillating. Okay, did you see what you did?
Oh, I just used the number, but it's still doing the thing with it was doing something. Sorry.
So what happens here is, as you look at what sine is doing starting at 0 and going out, referring back to the unit circle, what I want to do today is define a few things. As I go around the unit circle, how long does it take me to get all the way around it? 360, or in other words, 2 pi. So one full rotation of the circle is 2 pi. When you're looking at how things rotate and they go through, that's called the period. How long it takes for something to cycle through. All right? It rotates all the way through in 2 pi. Then it rotates again at 2 pi. It rotates again at 2 pi. It just keeps going and going every 2 pi. So if you're looking at the graphs of sine, everybody see how they just kind of, the wave itself just keeps repeating? It goes up, it goes down, it goes up, it goes down, it goes up, and so on and so forth. And the amount of time that it takes to go from one full up, one full down, back to start, this value from here to here would be considered a period. The amount of time it takes to go one full wavelength. All right?
Is it always the same time?
What's that? I think time is the wavelength, I guess we call that way. Because sometimes the period might be stretched. It takes a really long time for a wave to go. Any of you guys in physics? Physics is the practical application of all math. I'm telling you, if you guys like any bit of a science thing, physics class, it's fun. What you'll find out with sound waves are all sine curves. It's all trig curves. Low sounds take longer to oscillate. High-pitched sounds are quicker to oscillate. Their periods are shorter. The volume, the amplitude, how high up it goes. the higher the pitch, the louder it can be. The lower the pitch, the lower the curve is. That's why you want an amplifier that goes to 11. Not even you? You don't even get that one? Spinal Tap goes to 11?
Oh, God.
Probably to anybody, you would have saved me with a
I've
smirk.
seen the movie, I just.
Anyway, I'm disappointed,
No
yes.
idea
Spinal Tap. Anyway, so let's take a look at what happens. Do we all agree, in order to go all the way around the circle, we start at 0 and we end at 2 pi, right? Okay. So I start at 0, and I'm going to end it at 2 pi. What's halfway between 0 and 2 pi? Pi. What's halfway between 0 and pi? Half a pi, so we just call that pi over 2. And what's halfway between pi and 2 pi? 3. I knew what you meant. You were thinking the quarters. So what happens here is I want you to notice is that these spots are your quadrantals. Pi over 2, pi, 3 pi over 2, 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi. What are the values of sine at all those spots? Well, the value of sine at 0 is 0. The value of sine at pi over 2 is 1. The value of sine at pi is 0. The value of pi or sine at 3 pi over 2 is -1, and goes back up to 0. So what happens here? It oscillates itself through a graph, just like that. What's that? Yeah, and you notice we're not even bothering by looking at, pi over 3, pi over 6, pi over 4, any of those values in here, because those are just nastier fractions that have to graph. I mean, I could put 1/2 in here, for 45 degrees or for 30 degrees, 120 degrees and all that, and it does work, but there's no reason to. What I want to do is create a very simplistic way to show how sine looks in a two-dimensional graph. Okay. Now, what changes when you look at cosine? Yeah, it starts at cosine. It starts at 1. So let me put it on the same idea here. I would say y equals the cosine of x. I'll put that in red. If we go back and look at your unit circle, when you're at 0, remember the cosine values are the x ones. Instead, when it's at 0, you started at 1. At pi over 2, it's 0, -1, 0, and back to +1. So the only difference between a sine and a cosine graph is that one of them starts at 0, and the other one starts at 1. That's the only difference. It still oscillates itself through similarly. They both work the same way. Yeah?
So then you just y equals cosine.
Yes. Y equals cosine of x. You put it in your calculator. It's going to look. It looks exactly like a sine curve. If I move it, see how it's basically the same curve? It just has a different starting point. All right. It has a different starting point. That's all. So the differences between sine and cosine are very minute. One of them starts at 0. The other one starts at 1 when you're looking at the unit circle. Now, this isn't always the only thing you have to worry about when we're looking at sines and cosine graphs, because what fun would that be? A lot of times what we have to be able to do then is start to look at what are called the generic forms of the sine and the cosine graphs. And that's our goal today, to look at the generic form of a sine and a cosine graph. We are not going to worry about tangents yet. In this chapter, what I like to do is kind of break it into 2 parts. I like to worry about sine and cosines first, and then we shift them with the h's and k's. And then I worry about tangents and their shifts, because they're so different between sine and cosine and a tangent graph. They're very different. The way you set them up is different, but sine and cosine are so similar, it's easier to do. So,
For you to see what it looks like.
oh, it's you got the nice little waves, and then you got these. Yep. Yep. That was a great conversation we just had there. The whoop, and the whoosh. But the scary thing is we knew what we were talking about. Is that terrible? Notice we're identifying these curves off of just remembering the quadrantals on a unit circle. Did you notice on the test itself, when you had the non-calculator portion, half of the questions on that first sheet of the pink sheet were all quadrantals. Half of them were. So let's look at, we just did this one. Let's look at some bits and pieces here. What I don't want to do here is go over all of these simple, crazy definitions. What I want to do is define it off of the generics, okay? What I want to do is define off the generics as far as what amplitude means, what your period means, and all that. So let's take a look at generics. This is the most important. The generics of the sine and cosine graphs. The generics of your sine and cosine graphs are as follow. Y equals A sine B of x, and y equals A cosine B times x. I don't know if you notice I'm saying you probably should need to know this.
So A and B are always going to be positive.
A and B, they don't necessarily have to be positive, but when you're talking about the amplitude and the period, those will become positive. And I'm going to explain to you how all of this works. And as you do a couple examples of these, it's very, very simple. It's just following the same rules each time. So what we're doing here is this value of A. The value of A is what you call is going to be your amplitude. Now, when we look back at the sine function, remember, the graph that we had, it went up. It started at 0. The high point was 1. The low point was -1. The amplitude is that value of A. It's how high up does it go, or how low does it go. That's your amplitude. The period is how long it takes to go through one cycle. The period is always going to start out with sines and cosines with 2 pi in it. What you do to that 2 pi is you divide it by the value of b. You always want your period should always be positive. You don't want a negative period here. That's why they have that is with absolute values. Same with the amplitude. So when we're doing these things, remember, your A value and your B value, you want to identify those right away. Because your amplitude, how high it goes up the graph, is always the absolute value of A. And your period, for sines and cosines, is always going to be 2 pi divided by the absolute value of B. Like we said, your B value might be negative, but it doesn't make a difference because you take the absolute value of it when you work with it. B, I'm going to show you. Okay? When we went back to this first thing we did, we had y equals sine of x. What was our A value here? 1. Because there's nothing here, so A is 1. What was our B value? 1. That's why we were able to say that our amplitude was 1, and our period was 2 pi divided by 1, which was 2 pi. That's why that worked. What's going to change here now is when we start putting in different values for A's and B's. But you're going to notice that the only difference is in the graph is the graph might be taller, the graph might take longer or shorter to cycle through one revolution. That's it. When you plot them out, though, you're still going to use the same amount of space. You're not going to make them real scrunchy or anything like that. You're not going to use any standardized graph paper for any of this. You're going to set your period and cut it into its own quadrantals. All right, you're going to cut it into quarters. And you follow these simple steps that I do with this stuff, it's a cakewalk. All right? So let's look at some examples. I don't even want to bother with all this extra stuff here. Y equals 2 sine of x. When I'm doing these problems and I'm identifying them, the first thing I always want to do is identify my A value, my B value, what my amplitude is, and what my period is. For every single problem that we do in chapter 14 when it comes down to graphing or plotting and looking at these values, I am always going to do those same exact steps. Excuse me. So what is my A value? 2. What's my B value? 1. So what's my amplitude? 2. And my period will be 2 pi over 1, which is 2 pi. Okay? Bless you.
Thank you.
You all right? You okay?
Would the only difference be that the columns of it won't be at 1, it'll be at 2?
Exactly. Exactly. It's exactly right. So it's a sine function. First thing you do is you put your end spot of your period. You know your period's going to stop at 2 pi. You know it starts at 0. And we list out the halfway points. We'll call them critical values, if you will. What's halfway between 0 and 2 pi? Pi. Halfway between 0 and pi is pi over 2. And halfway over here is 3 pi over 2. That's the first thing you do. You put your end spot of your period, 0, cut everything in halves. Works every time. The book shows it a little bit differently. It shows you multiplying it by 1/4 and 1/2 and 3/4. That's fine if you want to do that. But I think by this point in time in your magical careers, you might be able to take half of 2, half of 1, I hope. Okay? Yes, ma'am.
So A can be a negative value, but the amplitude or whatever will always be like the absolute
Correct.
value of that value?
Correct. What will happen if the A value is negative, instead of going up first for a sine curve, where do you think it's going to go? It goes down first. Yeah, well, I have examples for that, and that's exactly what's going to happen. It just tells you if it's positive, you're going to go up first, and if it's negative, you go down first. That's all. The amplitude doesn't change. So I know, like you were saying earlier, instead of my amplitude being 1, my amplitude now is 2. So every single sine curve always starts at 0. It starts at 0 and it cycles itself through. You want to do that part now? All right. Oh, you get another one? Put your cup down. What is my name? So now, with the sine curve, it starts at 0, and it goes to your A value, goes back to 0, goes to the negative A value, and back to 0. It's still the same exact curve. It's a little bit taller. It's a little bit taller. That's it. Okay? That's all it did. It just shifted it to make it a little bit taller. All right? Notice my period is still the same because it was 2 pi. The only thing that changed is that my amplitude is new. All right? Bless you. Let's try another one. Y equals 1/2 sine of x. Y equals 1/2 sine of x. Once again, the very first thing I'm going to do is list out what my A is, what my B is, what my amplitude is, and what my period is. Okay? What's your A value now? 1/2. What's your B value? What's your amplitude? 1/2. What's your period? 3 pi. Very good. Now, I'm not messing with you guys yet about shifting your periods around. I'm just kind of keeping it easy, showing you how it works with the amplitudes to start with. So, you make your little chart. You start at 0. You end at your period. You break it up.
Now, when you break it up, do you have to mark every one, or did you put like pi and then 2 pi and then like division?
You have to have all. You have to mark them all, and that's one of the things that you're going to be graded upon when we get into these things more.
You have to mark that.
Yeah, you always want to mark your. These are called critical values. You always want to mark those quarters. Yeah, you do.
It's gonna be like the same like pattern over and over again.
Pretty much, yeah. Yeah. And now my amplitude is what? Huh? Well, when B changes, it just means that this part, the numbers change. I will after I do this one. So now my amplitude is a half. Do I have to mark it at 1 and cut that in half to draw this out the right way to make it look fancy? No. Just mark the A and the opposite of A. And now, it's a sine function. Where does every sine function start at? 0. Starts at 0. Since the A value is positive, it goes up, down, down, and up. Connect the dots. La, 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 la. Okay? Let's get to the scary stuff. Let's get to the point where you have to worry about your amplitude and your period. Y equals -2 cosine of 4 pi x. Forgot that. It would be helpful if you had that there.
Will B always be
Not necessarily. Not necessarily. Our last values, a couple examples, 3 or 4 examples that we've done, B was always just an integer. Sometimes B could have a pi in it, sometimes it will, sometimes it won't. All right? So just like we did earlier, what do you think your first step is? Identify everything. You identify your A value, you identify your B value. A is -2. B is 4 pi. You guys agree? What's your amplitude now? Your amplitude is always the absolute value. So your amplitude is 2. Your amplitude is 2. Right? Remember, amplitude is always the absolute value.
No, I'm talking about the next one.
The next one, okay, your period is always, for sine and cosine, 2 pi divided by the absolute value of b. Well, here it's 2 pi divided by 4 pi. What do you get? You get a half. 2 divided by 4 is a half. Nope. You don't need it. Exactly. Because here's what happens. Cosine. It still starts at the origin. What's the end of the period? Half. What's half of a half? Quarter. What's half of a quarter? An eighth. And what's halfway between a quarter and a half? 3/8. All I'm doing here, and if you can't work with the fractions, remember, this is your period. This is your period divided by 2. This is your period divided by, what would that be, divided by 4.
Is there,
What's halfway between 1/4 and 1/2? 3/8.
are we ever going to get some weird period like 3/5 or something like that?
Yeah, I don't think it gets that nasty. This is about as nasty as some of them get, in all honesty. It's just fraction work. Use your calculator.
Okay.
Seriously, that's all it is. It's just calculator work. All right? All you have to do is figure out, what's the distance between a fourth and a half? Fourth, right? So what's half of a fourth? Another eighth, so you add it in. That's all you're doing.
Wait,
Cosine's going to always start at, cosine always starts at your A value. Okay? Cosine starts at your a value, whereas sine function always started at 0. What's my a value here? -2, not my amplitude. My a value for cosine here is at -2, so I start at -2, and then I work my way up and back out. That's it. Remember, cosine always starts at your value of a. Sine always starts at the 0. It starts at 0 and then goes to the a. Cosine starts at a, then goes to 0. That's the only difference between those two functions. That's the only difference. So even though I threw a nasty shift into that, but with the amplitude being negative, or the a value being negative, and your period winding up just being, a half, it's the same thought process in how you set it up as every single other question or every single problem that we've done. Okay? That doesn't change. Let's try another one. What do we have? 4 minutes? Okay. All right, look at this one. I have 1/3 cosine of pi times x. Y equals 1/3 cosine pi x. What do you think the first thing we're going to do is? List out what everything is. A is 1/3. B is pi. My amplitude is 1/3. My period is 2 pi divided by pi, which is 2. There's 2, there's 0. I'll break it up. What's halfway between 0 and 2? 1. What's halfway between 1 and 0? In here. Well, 2/3 is in there somewhere too, yeah, but I'm looking for halfway. Yeah, exactly. There's no way in the world I'm going to try and mark off 1 and put in a 1/3 in here. No, here's 1/3. Why? Because I said so. Math is hard. Okay? So, just like she said, am I going to have to mark off where 1/3 is in correlation to like a 1? Who cares? It's right there. Here's -1/3. Cosine, it always starts where? Well, not always at 1/3 of this problem, yeah. It starts at your a value. And cycle through. A, 0, negative a, 0, and a.
Are we ever gonna have to find random points on the line?
No. These are what I'm getting you guys stuck with, are the critical values. The critical values are going to allow us to do our shifting tomorrow. These are all your parent functions. Here's what I want you to start on for tonight. Now, in these sets of problems, these first group are all about identifying what your amplitude is, what your period is, things like that, matching them to a graph. These last 6 are actually graphing, okay? So when you are graphing them, please get in the habit of listing your AVs out, what your amplitude is, what your period is, and as well as marking off your critical values, okay? So it shouldn't be, hopefully it's not that bad. Like I said, tomorrow we'll probably start with our shifting. And then Friday we might do tangent. Yes, ma'am.
What is the first group about?
It's like matching graphs. You just look at them and see if you match them up. Things like that. It's going to be, what happens with a lot of this what I want you to do, because it's going to be tricky for you. Not to say you won't be able to do it, but it's kind of nasty in your shipping. What you're going to get now are two back scanners. You'll have horizontal shipping. So you're going to get your, you're always going to grab your generic function first. And for each one of those points that we plotted, you shift them left, up, and right, and down, and have. You all done?
Yeah.
Wavier. Okay. It looks a little bit worse than it is. The tricky part is going to be is when you have to worry about where you're going to find out whether you're adding or subtracting or subtracting. So you might have to. Yeah. But what I want you to be able to identify is just like try and go through. Try to do a couple of sines and cosines, just the sines and cosines. It's 13, it's 14 too. So I would try and just get some of these sines and cosines out of here. That's fine. That's fine. Just give it a shot. We'll give you a call back up when you come back. It's not like 8:45-ish. It can get kind of messy. So if you get too nutty, too mad, too upset, it's not that big of a deal. And don't worry about tangent. Tangent is a whole nother world. I'm not even going to bother with you trying to again. Okay? If you want to take a look at tangent,
I think I'm good.
tangent can get nasty because your period is only pi instead of 2 pi. And you get asymptotes and you got to cut lots of things in half and stuff. So.
And then I'll try to check out some stuff. I mean, I'm pretty sure I'm going to have internet access and everything.
Oh, that's fine. Oh.